So we're going to look with this worksheet at some basic probability type questions here. So in the first one, we got in an experiment, it was found that 40 out of 50 bean plants died when placed in a certain soil. So what was the probability, our final answer we'll put as a percent, that the individual bean plant died. So you come back in here, you see you have 40 out of 50, write that as a fraction, as 40 over 50. And now we'll come back and remember, anytime you want to get something as a percent, you'll take the fraction, which is the probability here, and you go back and get it to a denominator of 100. So you have to do times 2 times 2. That will give me 80 over 100, which is 80%. Now, there's different ways to work this problem here. You know, some people may have reduced it down to 4/5 and then times 20, so about 80%. You turn it into a decimal as well, like 140 divided by 50, and get 0.8, and maybe decimal over 2 spaces to the right to make it a percent. Either way, you get 80% for that answer. Next one over here. So the probability of a pack of baseball cards containing a member of last year's All-Star team is 5/12. So what's the probability of getting a pack without a member of the All-Star team? So if you think of all the cards in the pack, that would be 100% of the cards. Now, when you think of 100% as a decimal, you would take the decimal. If you don't see the decimal, you know it's located in the back, so you can move it over 2 spaces. So 100% as a decimal is really just 1. And you can put the decimal back there if you want, but right the number 1, usually just leave it as just a 1 without a decimal. Now, if that's the total, so 100% would be the total, so as a decimal would just be 1 whole. So 5/12 represents, let's see, the member of the All-Star team. You want without a member of the All-Star team, that's key. Okay, so without a member of the All-Star team, so you're going to subtract the 1 minus the 5/12. 1 minus 5/12 to get this probability. These are what we call complementary events. So the total of everything will be 100%, which we saw was 1 as a decimal. You subtract the piece you have to get the piece that's missing. Now, 1 can also be written as 12. 12 over 12, 12 divided by 12 is just 1. When you say minus 5/12, that gives me my final answer here, 7/12. Come back over and circle these answers. Alright, so complementary events on that one there. Next one, this is some basic probability here. So you have a stack of 8 records. There's rock music on 5 of the records, country music on the other 3. I suppose Joe takes 1 record from the stack without looking. What's the probability that he would pick a rock music record? So 8 total records, that's my denominator. And this time we're looking for rock music. So the amount of rock records is 5. That goes to your numerator. You cannot reduce anything there, so you leave it as 5/8. Remember, when you're trying to find basic probability, you write that fraction as the number of favorable outcomes, in other words, what you're looking for as your numerator, and the number of total possible outcomes as your denominator. This time we had 5 rock records we're looking for, I have a total of 8. Jumping down here, number 4, you got 5 green, 4 yellow, 2 pink balls in a box. What is the probability of picking out a yellow ball without looking? So you come over here, let's get the total of this to get our denominator. So if you add up the 5, the 4, and the 2, you would get 11 as the denominator. And you're looking for yellow, so you see you have 4 yellow, so that'll be your numerator. Nothing goes into 4 and 11 other than 1, so you cannot reduce, so you're left with this final fraction of 4/11. Number 5, you're going to spin the spinner 1 time. So what is the probability of stopping on a 4, a 5, or a 7? So you see you have 8 possible choices to land on over here, so that's your denominator. So put down 8. And if you land on a 4, you're happy, a 5, you're happy, and a 7, you're happy. So 3 choices out of 8 will make you happy, so 3 is your numerator. That cannot be reduced, so therefore you're left with 3/8. When we check out number 6, you got 6 black socks, 5 white ones, and 4 brown ones in the drawer. So you're going to pick out 1 black sock. So what is the probability that you're going to pick another black sock without looking? So first things first, just like we've been doing in these previous problems, get our total. So if you add up the 6, the 5, and the 4, you'll get 15. And you're trying to pick a black sock out. So you see you've got 6 black socks. Now it says you pick 1 black sock out. So when he first went into that drawer, he had a 6 out of 15 chance that he would get a black sock. And it says he picked 1 out. So obviously if you take 1 out, these numbers are going to have to decrease. So if you take 1 out, put a little arrow here. The 6 goes down to 5, because if you had 6 black socks and you took 1 out, you now went down to 5. And if you had 15 total socks and you took 1 out, and we took a black sock out, that goes down to a 14 now. So when he tries to pull another black sock out, this will be his probability. So 5 over 14 there. So that one, just remember to take that step, because you took the black sock out, so you're trying to find that second probability rather than that first. And finally down here on number 7, you got this block and each side is painted one of these colors. You got a red, a blue, a yellow, a green, orange, and a pink. You toss it 48 times. What's probably going to happen? So you see you got these different choices here. So this is kind of like saying you have a number cube with, number 1 on one side and 2 on one side, 3 on the other side. So it's kind of like you're rolling dice here. Instead of having numbers, you've got these colors. So every side is the same size and shape. So everything's fair. So if you're talking about a theoretical probability, remember, theoretical probability is what you should get when you roll a number cube or do an event. So in this scenario here, each one of these sides, I'm going to put TP for theoretical probability. So if you were to roll a number cube or roll this particular color cube, each one of these sides would have a 1/6 chance of showing up, because you have 6 total sides. Each side is only up there, each color is only up there once. So if that's basically how many times you see a red every 1 out of 6 rolls, a blue every 1 out of 6 rolls, yellow every 1 out of 6 rolls, and so forth, you can now use a proportion to solve this if you're doing it 48 times. So take that 1/6. So for every 1 out of 6 rolls here, we're trying to figure out if you toss it 48 times, so your total will be 48, that'll be on the bottom. And you're trying to figure out what number to be on top. I'll put N for number. Remember, you can put any letter you want up there, you put a question mark, whatever. So you come over here, and if I solve this proportion, I could do times 8 to get from 6 to 48. I could do times 8 up here. So if you do it 48 times, you see that your missing number would be 8. So based on this theoretical probability, for every 1 out of 6 rolls should be one of these colors. That means 8 out of every 48 rolls should be one of these colors. So if you see the answer choices here, letter D, each color will be on top about 8 times will be your answer. So this is just some different stuff here for some basic probability. So this will be something that you can use again later on, especially some of these we're just writing the original fractions. This will pop up again on some of these other worksheets we look at in a little bit. All right, see you.